In this demonstration, I'm going to show how to use the database that's built into the Android stack. Now, it is an SQL Lite database, and we're going to cover the basics here. So, I've already built an application with 3 buttons, and when I click the buttons, it simply displays some text up here. What we're going to do is we're going to make it so that it interacts with the database. When you click Add, it's going to click and add a record to the database, and it's going to display it on the screen. When you click Display, it's going to query the database and display all records that are in the database, and Clear is going to wipe the database clean. So first, what is a database? Well, you can think of a database as a collection of tables. A table is basically a spreadsheet. So we're just going to use a single table in this example. You can do much more complicated examples where you've got multiple tables. But generally, you can think of it as having multiple columns. So here I've got a sample table that we're going to build. We've got the ID column. This happens to be generated by the tool. So this just refers to the record by number. Next is the data that we actually care about. So in this case, we're going to store a name and a student number. So here I've got a few pieces of information, or a few sample points that we can kind of just see for reference what it would look like. So we got the name and then a student number. Now about each of these columns we need to associate some information. So we need to, I'll put it here on the right hand side as we go, we need to have the type. What type of data is being stored? Well, here we're going to have an integer. The ID column is going to be an integer. The name column we're going to make a string, and then the student number we're going to make an integer as well. It turns out that the database cares what type of information we're working with. You can also store binary information in the database, although we're not going to do that here. So the next thing to realize is we've got to give everyone a column number. So this is column 0, 1, 2, and you can guess if you had more columns what those would be. You can have any number of columns in your table. So that's sort of the basics. We're going to make a system that represents this information in a table with the kind of information we talked about here. Now, what's that going to look like in software? Well, I happen to have a sort of a pseudo UML diagram here to help us understand what's going on. So imagine we've got our main activity here. We might have a bunch of activities, or other activities, some third activity, but we're just going to use a single main activity. It's going to interact with something called a database adapter that we're going to write, or rather, I'm going to provide. And this database adapter is going to know how to set up and query the database. It has an internal class called a database helper that's going to do some of the little bit of a grunt work for us, and between the two of these, they're going to interact with the actual Android database. I would normally draw this as a cylinder, but this tool doesn't have one here to show. So that's sort of the basic framework we're looking at. We're going to mainly be looking at this, writing this activity to use and interact with some database code. We'll see that code here, and we'll have to copy this in. So that's something that we're bringing in, which is I'm providing some sample code for. So let's carry on. Let's see how we can actually make this work. So the first thing we want to do is sort of understand the process. Well, let's see what we've got to begin with. So here is my activity that I've created, my 3 buttons, and then in the middle here I've got my text field. When the application runs, we can see it looks exactly the same. I've set it up so that there's an on-click listener here for each of these. So the on-click event calls over to some function inside of my activity. For example, on-click underscore add record. This one is clear all, and display records. So let's look at that in the code. So here are my 3 listeners for add, clear, and display. And at the moment they each just call this function display text with a string. What is that? Well, it's a simple function I wrote up here. It's a private function, and it's going to take in a string. That's the message we want to display. And then it finds the big text box on my display, which happens to be named text display, find view by ID, casts it to its text view that it is, and then sets the text on screen. So that just kind of gives me a bit of an abstract way of interacting with the UI. Of course, when we create it, I'm not doing anything here special in the onCreate, and let me just make a quick change here. I'll add an exclamation mark after each one of these, and then we can see that we actually made a change. Control F11 will cause it to recompile and re-download. And then we have our applications running. So now what do we do? Well, if we go back to looking at the UML, we said, well, we've got this main activity. It needs to interact with our database adapter. Now I don't want to go through writing it all. It's a fairly long class to work with. So what I'm going to do is I've already got it written. I'm going to copy and paste it in. So I've gone to File Explorer. I come into here and I'm going to go right click and say paste. So here's my database adapter. I'll double click on it. We come into here. And we see that it's all nicely laid out. This code will be below this video in the YouTube channel. So it's not particularly long, as you can see here, but there's a fair amount of code, a fair amount of constants defined, and we're defining some SQL as well. First thing we need to do is we need to change the package. I can go Control-1 and let Eclipse do that for me. Change package declaration to match the current package. And fix that. Save the file, and now it's happy to compile. We'll come back and look at this later. To begin with, we're going to use it, and then later we'll actually analyze what it does for us. So I'm going to write up here sort of the steps to using the database. So the first thing we're going to need to do is we need to instantiate the database adapter. So we're going to instantiate. Next thing we're going to do is we're going to open the database. Third thing, we're going to use get, insert, delete, and so forth to change data. And then finally, we need to close the database. Now how do we do this? Well, let's do the open and close first. Well, rather, I guess the instantiation of it. So we need to create an instance of the database. We want it to be accessible all throughout our activity, so we're going to make it as a field to our class. So for it to be a field, we're going to instantiate it. It's called a database adapter, db adapter. I'm going to call it my DB for my database. So this is the variable that's going to hold it. And what I'll do is inside of my onCreate, I'm going to create a new function, and let's call it open database. I'll go Control-1, and it's going to create the method for me. And I'm just going to drag this down. Actually, where it is fine. So I want to open the database. The first thing I do is have to instantiate it. So my DB is equal to new database adapter. And it needs to take in a context of what to work with. And so we're going to give it this. It needs an activity to be able to interact with the Android framework. So now I've created one. I still haven't actually gone through and opened it. So I can say mydb.open. Now it's opened the database. So that's first one. What I'll do is here is I'll say done. Now another thing we do is every time we open the database, we do end up needing to close it. But how can we close it? We do have this function called onCreate. If only there was a way we could have it so that when the application is going away, it calls some other piece of code. And there's something like that. It's called onDestroy. So I'm going to right click, and I'm going to go down to source, which is Alt-Shift-S. So let me just try that here. Alt-Shift-S, and I'm going to override or implement methods. And here in my activity is a whole long list of things that the activity allows me to override, and I'm going to look for onDestroy. OnDestroy. There we have it. Click OK, and we now have the onDestroy overrided. So we're going to call the super for onDestroy. That's the first thing we want to do. And after that, we're going to call close the database. What's close database? Well, it's a new function we're going to implement. So I'll go Control-1, create it, and here we have it. I like to keep all of my methods in very kind of short, succinct, and well-grouped, good groupings between them. So here we have an on open and a close, and the close is going to be very simple. I'm just going to call my database.close. So I open it, I close it when it creates it. So that's not going to do anything. Let's just make sure it doesn't crash. I'll go Control F11, test early, test often, and see if it works. We're not going to see anything noticeable other than just it actually executes. So exact same behavior as before, and I click back, it leaves fine. No crash. Okay, good. So let's go back up to our list here. We've opened it, we've closed it, now all we have to do is use it. So we're going to do this get, insert, delete, and all that other good stuff. Well, how do I do that? Well, we've got here, let me just give us some space, we have all of these functions that we're going to call back into. So let's start writing the add first. So we're going to add a method to the database, so we can go myDatabase.insert, and we use the insert row. Now, this function happens to want a name and a student number, as we see here. It's been written to work with the tables that we're working with. So if I go back and look at the actual table I'm working with, we see that each record, for example this record here, it needs a name and a student number, and we said that this one would automatically be provided for us. So all we need to do is provide a name and the student number to insert a new row. So I'm going to insert, I need a name, so let's give it Waldo, and I need a number, let's do 987. Pardon me, and it's insert row. There we go. So insert row. Now if we look at this insert row, it's going to do something. It's going to return to us a long. So let me control click that, and we see the code. It's returning a long, and we can see it's actually going to be the ID that we're going to work with. So I'm going to capture that. So long, new ID. Now when I run this, it's, it'll execute, but we're just sticking things into the database. We're not yet looking at what happened. So we'll come back to using this ID in a minute. So I'll rerun that. I'll click add. It's adding things to the database, but I can't see anything. So let's implement the display. So when I go to display, I've got to ask the database for the set of information that I want, and then I have to display that to the screen. Now if you're familiar with the idea of an iterator, we're going to use something very similar. It's called a cursor. So when you query the database, it generates a record set. The cursor allows you to step through that record set. So I'm going to create a cursor. Let's call it cursor. Equals myDatabase.getAllRows. We see here it returns a cursor. Now what am I going to do with it? Well, I write some code to actually step that through. I could do it right here, but it turns out we're going to need this code a couple times. So let's create a function for it. Display record set. And I'm going to pass it in my cursor. So I'll come up here, Control 1, and we're going to import the Android database code. Of course, display record set doesn't exist, so let's create one. Create the function. So the idea here is we're going to display an entire record set to the screen. So the basic structure here is I'm going to create a string, message equals, let's give it something to start with, and then I'm going to populate the message from the cursor, and then I'm going to display it to the screen. I just happen to have a function to do that, so display text, and I pass it in the message. Why are we having a compile problem here? Message cannot be resolved. Oh, I misspelled that. So if I were to run this, it would simply display hi to the screen. Well, this whole populate the message is, of course, the interesting part. So what's that going to look like? Well, I get back my cursor, and the first thing I need to do is I need to reset it back to the start. So reset cursor to start, checking to see if there's data. So if, and we're going to say here, we have the cursor dot move to first. It returns a Boolean, and so if we're able to move to the first, then I need to process the data. So what I'm going to do is I'm going to loop through a bunch of them. So let's start off with creating sort of pulling out the one I want. So int, I'm going to come up with an ID. So I can ask my cursor for the one that I'm currently pointing to. I can say get. And there's a whole bunch of gets here. So I can get int, get string, and so forth. So the first one is get int. I'm going to get the ID. This is created by the tools, so get ID. And now I need to give it a column index. I could put 0 here. That's going to work. But it turns out that that's then hard-coded to the structure of the database. If that changes, the hard-coded values are just a terrible idea. I'll fix that in just a minute. So I'm going to duplicate this. We're going to create a string, another ID. The string is going to be the name, And the ID, well, that was the student number, or just the number that we were inserting into the table. And then, of course, I don't want to get an int here. I want to get a string. It's column 1 and column 2 for my student number. This is going to pull out all that information for me. And then I need to do something with it. So let's append data to the string, to the message. And so here I'm just going to say message plus equals the ID is equal to the ID. I'm going to have here the name is equal to the name. And I need to put a few pluses in, don't I? The number is, let's just do number sign, keep it short on the screen, is equal to this plus the student number. And let's put in a line feed. Okay, so what do? I extract the data, and then I take the data and I stuff it in a message, and finally I pass the message in here. Of course, I want to start off with an empty string, so I'll get rid of that. Now this is going to only process one record. Let's first see if it actually works. So this is only one record. It's at least going to be an interesting start to see if we get that functioning. So I'll display, and here we go, we have the information. I'll add another one. Of course, we're still getting just the same piece of information because we're only asking for the one thing. Of course, we haven't implemented clear yet, so it's not going to do anything. So let's go back and let's process the whole set of data. What I want to do is, well, inside of here, I'm actually processing it fine. I just need to process it a bunch of times. So I'm going to add a loop. I'm going to do the following a bunch of times. Do this while we have a cursor dot move to next. So it's sort of the iterator semantics. Slightly different though. Now, the one funny thing about a cursor is you need to close a cursor. So I need to call cursor.close. Otherwise, you end up with a resource leak. Put a comment here. Close the cursor to avoid a resource leak. Okay, now let's try this. Hopefully, when this executes, we'll be able to see all of the data that's inside of the database. Now there's going to be a fair amount of it here because we've clicked that add button a whole bunch of times. So display, and then we have all the data. Note that our data is always the same. Why? Well, it wasn't ever changing. We're always adding Waldo and the student number of 987. But we can see here that the IDs are always incrementing. So let's add another one here. Display. There we go, we have 9. Add 10. We see that we keep adding up. So let's go back here and figure out. I don't want the empty string there. Now, let's go through and make it so we can wipe the database. This turns out to be quite easy. So this clear, I can simply call my database dot delete all. And we've implemented that to execute an SQL query that's going to wipe the database. So I'll re-execute this. Display, we have our data, clear, display now, and it's empty. If I add 1 and display, I have 1 element. Now what I want to do is I want to make it so that when I click the add button, right now it's going to add number 14 for example, let's make it so when I click it, it actually shows me the record that it just added. Only the one record that we just added. So how do we do that? Well, remember I said before that we'd use this ID. When we insert the row, it's returning to us a long. That happens to be the ID of the record that was just added. So we're going to actually go through and use that now. So let's say query for the record we just added. And to do this, we're going to use the ID. So I create a cursor. Let's call it cursor equals my database dot. Now I want to get just a single row, so here we have this function called getRow, and it takes in an ID, so the row ID. New ID, I'll pass that in. Now what do I want to do with this cursor? I could cycle through it, display it to the screen, and wait, I already have a perfectly good function that does that down here. Display record set. So let's just call it display record set and pass in the cursor. That's nice because it's going to handle all the work for me. It's going to loop through, it's going to display it, and it's going to close the cursor. So let's try that. So let's display, see what we've got. So next we're expecting 15 to come up, so I'll click 15. There we go, it added. I'll keep clicking add, and we can see that it's now displaying just the one record we want. I click display, and here we have all this data. So what's going on there? Well, our display routine is still the same. We take the entire record set we're given, and we display it to the screen. The difference being, the record set we've got, you can think of it as more like an array list or a list of data. It's only got one element in it. It's a list with one element. So we get a record set when we call this getRow. We query on what's known as the primary key, and so we get back a single row of data. Whereas down here, later on, we called getAllRows. So that gives us a record set containing all the data. Okay, so now we've gone through, we've added the data, we've seen how to clear it, and how to work with it. Let's actually see some of the magic, if you will, behind the scenes. What's been going on? Well, we've been using this thing, the database adapter. So my database here was defined to be, way at the top, a database adapter, which we then instantiated and opened. So let's look at what's going on inside my database, or the database adapter, pardon me. So in here, I've got it nicely commented about all the things you have to do with to-dos. So we need to change the package to match the package we're in. We carry on, we say, well, okay, to use this, look for the to-dos. So we see here's change number 1. We need to set up our fields here. So we're setting it up one to be a name, and the second field to be a student number. These are the columns inside of our table. Name, student number. If we wanted to add another column here, I could, if I was going to give it the name of, say, favorite color, let's call it fave color. Fave color. And we're going to want to make this to be, I'll move this over. We're going to want this to be a string. And this is going to be, of course, column 3. So let's see what that's going to look like. So I want to add a new one here. So I'm going to duplicate the line. That's Control-Alt-Down, duplicates the line. And we're going to call this fave color. And here we put fave color. So I've given it a name for the column. This is what's actually going to be in the database. So the database column has a name. Now when I go to access it, it's going to come up to be a column in the record set. So let's give it a number. So fave column, or fave color, is going to be column 3. Again, we're just kind of counting up here. Next, we see here we have a string, an array of strings named all keys, and it's got the names of all the keys. We got the key for the ID, the row, we got the key for the name, key for the student number. Oh, and we just added one, so let's put that in. Key for the color. This again is going to be used when we create the table. I've got it, I'm naming it my database, and I give the table a name. I'm only working with one table here. You could work on expanding this to use multiple tables if you knew databases very well. Now when I go and create it, well, I've just made a change to this, so I'm going to give it a new version number of the database. It's going to wipe the old database, create a new one, because I've added a new field to the table. It's not very expandable that way, so make sure you get the database design right the first time, or your data is going to be destroyed. Now when I come back in here, we got the code that's going to generate it. If you know SQL, you'll recognize that this is just an SQL statement. This is one large SQL statement. It's going to create a table for us, and we're going to duplicate this functionality so that we actually generate the table we want. So all I want to do here is I'm going to put in a new one. This is key, and we had the name was column. Fave color. It is going to be a string, and we're not going to allow null, meaning we need to have the data there. Now, one interesting thing as we look through this, we see that commas are important. We need a comma here because we've got more coming up. And the last element cannot have a comma. So the last one must have no comma. So now I've added that new piece of information. We keep walking through. We set up some context. Most of these functions now will automatically adjust themselves. Open, close are fine. Here we see we've got to do more work. So we're going to insert a row. I now need to insert some color as well. I could overload this function if I wanted to. I'm just going to actually change it. So string fav color. This is going to mean we're going to have to change our main activity to actually call this as well, but that's all right. And so I'm also going to want to put into this thing that I'm creating the key fav column, or fav color, pardon me. And so we'll insert that into the data. It gets pushed into the database. Here we're going to delete a row. We don't need to change that. Deleting all rows, don't need to change that. Getting all rows, well, that's fine. We're just querying everything. Get a single row, that's also not needing to change. So we can see that most of this comes along. And we've got this function here for update. Update's going to allow us to change an existing one based on a row ID. So here I need to pass in the string fav color. And it's very similar code to the insert, except when it executes, it's going to do an update. So here this is going to be fav color and fav color. It now executes a database update, whereas before we were doing it at database insert row. And then finally down here, this is that database helper I was talking about before. It's an inner class. Let's have a look at the UML. This database helper is used by the database adapter. It's a private inner class that nobody else needs to care about. And it just does some of the grunt work for us with the database. So it executes a SQL query for creating the database, and it can upgrade the database as well, so switching from the old version to the new version. And that's in fact what we're going to do here because we've just added some more information to the schema of the database, i.e. added columns. Okay, so if I were to try and run this now, of course it's not even going to compile because main activity is unhappy. Why? Let's have a look. So you see on the right hand side, it's unhappy at this point, so I can click on it, it takes me to the line, insert. Well, the problem is that we were previously passing in only a single string and a number. We now also need to pass in Waldo's favorite color. So let's change this. Let's call it Jenny, and Jenny's number is 5559, and Jenny's favorite color is green. And all the rest of the information here would be the same, except down here when we go to display it, we're passed in a cursor to a record set. So I want to pull out some extra information. I'm going to also pull out the fav color. And we're going to get a string, and this happens to be the third column. Oh, and I was going to fix these too. We'll look at that after. So I'm going to insert here the color is equal to fav color. Oops. So let's run this and see if it works. May not. We might have missed something. We might have had some small change. Now note that we had elements 11 through 20 in that data set. That was what that database contained. Now we have nothing. Why do we have nothing? Because we changed the version of the database. That little version number we had stored there, that was simply indicating the sort of schema version. We changed schema version, so it blew away the database. So let's add an element. You see that we just added ID 1, name was Jenny, number was 5559, and the color was green. If I display that, same thing. Let's add a bunch more pieces of information. And here we have all this information. So now, this is stored in the database. The great thing about it is if I leave the application, I could go and find it, but let me just hit Control F11 to rerun it and re-download. It's going to have that data still. So display, and here's all the information. So it's a persistent storage. It's better than using the shared preferences because we're able to store much more information in a much more complicated fashion. So we can, for example, store binary data. We can store much more wide variety of information in a much more efficient manner. So that one last thing I wanted to do is get rid of these magic numbers. Magic numbers are terrible. So let's go into the database adapter and figure out what we can use. We wanted, for example, the numbers 0, 1, 2, and 3. Well, I just happen to have those numbers here. Well, are they what we wanted? Column for the row ID. Well, that sounds like what we want. So I'll copy that, come back in here. I can't just paste it in straight because it doesn't know where that is. So I've got to say, well, this is from the database adapter dot column. I can do the exact same thing for the next ones, except I don't want the column. I'll copy and paste this. I want this to be, I'll go control space. This one was the name. This one was the student number. The final one was the favorite color. This is the much better way because now we're completely decoupled from the order in the tables. If the database were to change and reorder the columns in the table, this would now update correctly because we're using the named constants. The numbers, for example, 5, I've got no idea what column 5 is. But if it's got a name, that's exactly what I need. So I'll just rerun this one last time, and we can see what's going on. So I'll display. Seems to work fine. Add number 6. Display that here. Now if I clear, we get rid of all the data, but the next one comes back as ID 7. So the database is ensuring that we get unique IDs on these. So that's it for the demo. What have we seen? Well, we first looked at how a table is organized and understood what that's going to look like in the database. We looked at the UML and saw how our activities could instantiate a database adapter. The database adapter then uses the database helper and connects to the database in an interesting internal way. We looked at how we could write the code in our activity. So we had all these callbacks to some functions. We saw that one interesting thing is that most of our calls generated a cursor. So from the cursor, we could then loop through data, as shown here in my display record set, and we could pull out all of the information from that cursor, that record set. Remember, we always have to close our cursor, otherwise we end up with a resource leak. Even though Java does automatic garbage collection, we still need to tell it that we're done with it. And then the other thing we learned is that we need these sort of primary keys, or these IDs. So when we insert the row, we get back an ID, and we can then use that to query directly. So if you wanted to, for example, reference from one table to another, you'd insert those primary keys, those record IDs. Alright, thank you for viewing. I might have some more videos on how to do more complex things with databases and process that information later.